Hello again. Before I start explaining the new section here of statistical significance of RP or Pearson correlation coefficient, I'd like to say something about correlation and the correlation analysis story. So if you think that the correlation analysis story ends when you calculate the Pearson correlation coefficient, so you are wrong. Because actually it's not the end, it's the beginning or the start of a new story, which is the story of statistical significance. So what is it, or what is meant by statistical significance, and why I am supposed to check the statistical significance of my RP? Let me tell you that if I'm going to explain what is statistical significance or level of significance that I'm going to talk about later, I'm going to take like 2, 3, or 5 videos to explain it, because it's not something easy to understand. Yet because my job now is to simplify things for this semester, I'm going to give it to you in simple terms. So I want to take you back to the exercise or the activity we did together to calculate the Pearson correlation coefficient. So we ended up after the calculations by finding that the RP equals 0.9, if you still remember. So this 0.9 is supposed to tell me something about my correlation. But let me tell you something, that this 0.9 is just a number. It means nothing and it is meaningless unless it is statistically significant. So if I want to make sure that really this 0.9 or the Pearson correlation coefficients or any correlation coefficient I calculated is really a real indication, a real indication of my correlation, I would like to check if it is statistically significant or not. Okay, so this is it. And the statistical significance means that, or refers to the level of confidence I can give to this number I obtained. Is this number really indicates the existence of correlation, or it's just a number there? So I hope this can help you understand a little bit what is meant by significance. Significance, of course, does not mean meaning or importance or something like that. No, it has to do with the level of trust, the levels of confidence I can give to the number I obtained from the calculations and the long process of calculations. This is concerning statistical significance. So make sure again, if you calculate by yourself the Pearson correlation coefficient, or you use even a software like SPSS or Excel or any type of software, statistical softwares, the RP, the value is not enough. You have to find the statistical significance as well, because the statistical significance is the proof of the existence of a correlation, not the value of RP. So, to conduct statistical significance analysis, you need to go through some steps. Of course, there are many methods to measure or to make sure or to examine the statistical significance of RP, but I selected the easiest one, which is the critical values of R, using the table of critical values of R. So the first step in doing so is stating your hypothesis, because we are here testing hypotheses since we are in inferential statistics. Now, what are the hypotheses? So you have to state one of the hypotheses, the H0 or the null hypothesis, or the alternative one. So the H0 says, or the null hypothesis says, that there is no statistically significant correlation. And the alternative one would say the opposite, so there is a statistically significant correlation. So let's say you have two variables and you want to examine whether they are correlated or not. So the first step is stating the hypothesis. So which would be the null hypothesis or the alternative one. And we are going to test which one of them is acceptable. The second step is calculating RP. Just calculate your coefficient in any method I showed you. So any method, let's say the simple formula or the standard deviation method. Just after that, indicate or find your degree of freedom. The degree of freedom is something easy to find because it has to do with n, which is the sample. So whatever sample I have, I'm going to have a related degree of freedom. So if, let's say, if my sample is like 9, so my degree of freedom is 7. If my sample is 5, my degree of freedom is 3. After specifying your degree of freedom, you need to select a level of significance. Level of significance, statistical significance. So what level I'm going to test my statistical significance of my RP in. So alpha is the level of significance. You have to know that we have so many levels of significance, but we are interested in human sciences only in 2 levels of significance, which are the 0.05 and 0.01. Okay, you may be wondering, what is 0.05 mean, or what does it mean actually? So this is a percentage, which is 5%, and this one also is a percentage, 1%. So if I want to write a percentage in terms of numbers, this is how it should be written. The 5% is 0.05. But what does the 5% mean? The 5% mean here that this is the times, or the percentage of the times I'm going to get wrong results. I'm conducting my correlation over and over and over with different people and different situations. I'm going to fail 5 times out of 100. So if I'm repeating my correlation over and over and over in 100 times, I'm going to fail 5 times. Or the results I'm going to obtain are going to be wrong just like 5 times. And the rest, 95% or 95 times, are going to be right. So I'm going to succeed in my correlation, and the result I'm going to obtain are trustful 95%, which is a good percentage for success. Only 5% I'm going to fail. The same thing here for the second level of significance. So it's 1 time. So in 100 times of repetition, I'm going to have true results, good results 99 times, and fail just once. Okay, so this is the simplest explanation of the levels of significance. After selecting your level of significance, you need to use the table of critical values of RP to find RT. What's the difference between RP and RT? RT here means, the T here refers to tabulated. So this R is not your business. If you have calculated this R is already calculated by statisticians and put in on a table, which is called the table of critical values of RP. Critical values of RP. So all you need to do is take your degree of freedom, select the level of significance, and go to the table. Here is an example of a table actually. Here is a table. I don't know, I think it's clear. So as you can see here, the table of critical values of Pearson correlation. It's already written. And here we have level of significance for the one-tail test. And in here we have the levels of significance. Now let's check here. So this level is 0.10, this one is 0.05, 0.025, 0.01, 0.0005, and so on. The levels of my interest are these, as I have already explained, the 0.05 and the 0.01. Here is the DF. If you can see, here is the DF, degree of freedom. And here, 1, 2, 3, 4, and you can have millions of degree of freedoms depending on what you need exactly, because you're not going to go through all these values and all the degrees of freedom. You are going to work with your degree of freedom, which has to do with your sample. Let's say my degree of freedom is like 4, 5, or 3. So I'm going to follow this line. So I'm going to work with only the values on the line. And then what exact values are those that match the significance levels, the first significance level and the second significance level? The 0.5 and 0.1 in here, like in this case. Now I think that you know how to use this table. All you need to do is specify the levels of significance and the degree of freedom. And again, the degree of freedom is specified by the sample you are working with. After specifying them, you will end up by finding an RT, a value or 2 or 3, depending on the levels of significance and the degree of freedom. You're going to end up by having an RT. What to do with this RT now? But before moving to the next step, I'm going to tell you something about this table. This table is found everywhere, in any statistics book and online if you want to Google for it. And there is not only a table for critical values of Pearson, there are many tables for critical values of different statistical tests. Let's say t-test, chi-square, and any other test, so not only for Pearson. That's why you may find different types of tables. Now, I have an RT, what to do with it? Here comes the next step. So compare the value of RT you have found to the value of RU calculated, okay, RP to RT. You will end up by having two cases. Let's say that I have found the value of RI calculated is more than the value of RI found on the table. So what am I going to say here? Here we can say that there is a statistical significance. In this case, you can be happy because this means that there is a correlation. Okay, in this case we are going to accept the H1, saying that there is a statistically significant correlation between my variables. Okay, we have to go back to the hypothesis and accept one of them and reject the other one. So if I'm accepting this one, automatically I'm rejecting the 0 one that says that there is no statistically significant correlation, because we have a correlation actually. If my RP is less than RT, in the second case, here there is no statistically significant correlation. There is no statistical significance, and this means that we have no correlation. In this case, we are going to accept the 0 and refute the alternative hypothesis. Now, if you still remember, I said that the correlation coefficient isn't the proof or the indication of the correlation, it's the statistical significance, okay? So if there is a statistical significance, there is a correlation. There is no statistical significance, there is no correlation. I think that analyzing statistical significance of my R is easy. All you need to do is calculate it, find the degree of freedom, select the level of significance, just go to the table and compare the values you have. For more understanding, I suggest this example. Here's an example. I'm taking you back to the example we have used to calculate our RP. So, if you remember, n was 5, RP we have found it's 0.9, and the degree of freedom is n minus 2, which is 5 minus 2, which is 3. Okay, now let's look for, since we calculated R, let's look for RT. Again, in the table of critical values here, as you can see, I don't know, okay, here. So my DF is 3. Let me use this one. So our DF is 3, here it is. And it means that I'm going to follow this line. Okay, the levels of significance I'm going to work with are the 0.05 and the 0.01. So I'm going just to come here. So here is it. Here is my value. It's here. So my first RT is 0.005. And my second value, just go here, is 0.934. 0.934. Now I don't need this table. Now here is how we are going to answer. At the level of significance, or at the significance level 0.05 and the degree of freedom 3, RP we calculated was 0.9. That was 0.9 is more than the RT, which is 0.85805. Okay, so 0.9 is more than 0.8. Here, what can this say? It says that there is a statistical significance, which means, yes, we have a correlation. It means that we accept H1 and we say that there is a statistically significant correlation between X and Y, my two variables. If you remember the activity we had, the two variables were the statistics exam scores and the research skills exam scores. So there is a correlation between them. Now, at the level of significance 0.01 and the degree of freedom 3, our RP, the one we calculated, which is 0.9, is less than the RT, the one tabulated, which is 0.93. What does this mean? It means that there is no statistical significance, which means that we have no correlation at this level. And here we are going to accept H0 and reject H1. H0 or the null hypothesis says that there is no statistically significant correlation between X and Y. Of course, in our case, we are going to select this level because this level we are going to work with. So you're going to say that my study is realized and there is a correlation in this level, and just avoid working with this level. Okay, I hope that you got it, and if you have any questions, just leave them with the video, and this is it.